A very good evening, students. So today we are going to do unbalanced assignment problem. In earlier video we have tried to make solutions of balanced assignment problem. So here is the question, but before starting the question I would like to explain the difference between balanced and unbalanced assignment problem. In earlier video I have explained you that to solve the assignment problem we are in need of a balanced matrix. Now what is the balanced matrix? Balanced matrix means the matrix which have a number of rows equal to number of columns. Number of rows are equal to number of columns, means that we have a 5 rows and 5 columns. If we have a 4 rows, then we have a 4 columns. So that is a balanced matrix. And to solve an assignment problem we are in need of a balanced matrix. So whenever we are going to get an unbalanced matrix or unbalanced assignment problem, first of all what we have to do, we have to make it a balanced assignment problem, or we can convert it into the balanced matrix. Okay, so let's read the question and then we will talk about the question, we'll discuss it and we'll try to solve it. So a chartered secretary firm has 4 chartered accountants, each of whom can be assigned any of 3, that is a question number 46, 3 audit assignments. Because of the varying work experience of the chartered accountants, the net surplus, which is professional fees minus expenses to be incurred by the CS firm, varies is and as under. That is the chartered accountants or chartered secretaries. These are the audit assignments, and the elements which has been given, that is 65, 75, these are the surplus, net surplus. Is it okay? First of all, let's see that whether this problem is balanced or unbalanced. So you can see number of rows are A, B, C, D, 4 rows, and number of columns W, X, Y, 3 columns. So that's why it is unbalanced problem, because number of rows are not equal to number of columns. So we are going to make it balanced. How to make it balanced? We are going to introduce dummy row or column as it is required in the problem. So in this problem we are falling short of a column. We don't have an assignment because we are in need of 4 audit assignments. So we are going to introduce a dummy assignment, and the values to be put there in the dummy column or dummy row will be the zeros. Every element will be the 0 in the dummy row or dummy column, whichever we are introducing. So in this case we are going to introduce a dummy column, and that the values in that column will be the zeros. I think you guys have got it, that how to solve, or you can say how to convert the unbalanced problem into the balanced one. Okay, so from that, now I think that you guys have got that this is a problem of unbalanced and how to convert a unbalanced problem into a balanced one. Is it okay? Now let's see that whether this question is of a minimization or maximization. So while reading the problem we have came to a word that is a net surplus. Net surplus means the profit these firms, the chartered accountants, are able to generate. So if the elements given in this matrix are net surplus, then it is a problem of maximization. And in the case of maximization problem, what we have to do, we have to convert our maximization or our profit matrix into a loss matrix or in a minimization problem. So that will be our profit matrix. And we are going to convert that profit matrix into a loss matrix. And how we convert our profit matrix into the loss matrix is we are going to choose the largest element. We are going to choose the largest element available in our matrix and reduce each and every element of matrix from that largest element. The values we will get in our new matrix will represent our loss values or loss matrix. Thereafter, the method to solve this problem will be the same as we have done it earlier, because we have converted the problem of maximization into the minimization. Is it okay? Now let's try to do the question on a notebook. So I have noted down the problem on this page and we'll try to sort it out. So we have a 4 rows and 3 columns. So we have to introduce a dummy column. So I'm introducing it here with D, and the values will be 0. Now this problem has been converted into the balanced problem. Earlier it was unbalanced because the number of rows were not equal to number of columns. But now it is a balanced matrix or balanced assignment problem because the number of rows are equal to number of columns. Further, now it has been converted into from unbalanced to balanced. Now let's see that whether this problem is of a minimization or maximization. As we have discussed in our question, and we have found the word net surplus, so this problem is of a maximization. And if this is a problem of maximization, then this is a profit matrix. And if we want to solve this problem, we have to convert this profit matrix into the loss matrix. So we are going to write out conversion of profit matrix into loss matrix. How to convert? We are going to find out the largest element. In above matrix, which one is 65, 78, 83, 83, 85, 85, 85, 85, 85, 85. That is the largest element. We will deduct every single element in the matrix from the largest element. Every single element of the matrix from the largest element. Let's do it. W, X, Y, D. So here DD, so we will use DU. DU. A, B, C, D. So largest element is 85. So every element should be deducted from this one. So 85 minus 65, that is 20. 78 should be deducted from 85. 85 minus 78, that is 7. Again 85 minus 83, 2. 85 minus 0, 85. 85 minus 85, 0. 85 minus 52, 33. Minus 59, 26. It will be 85. 85 minus 83, 2. 85 minus 56, 29. 85 minus 69, 16. Again 85, because 85 minus 0, 85. Thereafter 49, 36, 5, 0, 85. Now this is our loss matrix. Once we have obtained our loss matrix or our minimization problem, we can also call it minimization problem, as we have converted our profit matrix into loss matrix. Now the simple steps which we have earlier discussed: row reduction, column reduction, making assignment, further improvement, and again making assignment, fill, again improvements, and whenever we are going to get our solution. And where we are going to get our solution? When number of assignments are equal to number of rows or columns. Is it okay? So that is our loss matrix. Now let's start our row reduction, our column reduction. Okay, so let's start. Here it is, row reduction. From here the problem is same in every case. If you have a maximization case, then convert it into the loss matrix. Okay, so row reduction, the smallest element in the first row is 2, so 20, let's write it wx y du b c d. 20 minus 2 18, 7 minus 2 5, 2 minus 2 0, 85 minus 2 83. Thereafter 0, it will remain same, 0, 33, 26, 85. Next, smallest element is 2. Here was 0, 2, 0, 27, 14, because we are reducing 2 from every element of the row. Here will be 83. Okay, and let's write the same because the smallest element is 0, so the values will be same, 36, 5, 0 and 85. We have done the row reduction. Now we will do the column reduction. So here it is. Let's see that each and every column has a 0. No, we don't have. So w x y d a b c d. So first column have a 0, so values will remain same because 0 is the minimum element. 18, 0, 0, 36. 5 is the smallest element, 0, 28, 22, 0, again 0, 26, 14, 0. Smallest element is 83, so 0, 2, 0, 2. Okay, now we have performed row reduction and column reduction, and our third step is to making assignment. And how we make an assignment? We are going to find out single zero, firstly row wise, then column wise, then row wise, then column wise, then row wise, then column wise, then row wise, then column wise. Means firstly first row, then first column, then second row, second column, third row, third column, fourth row, fourth column. Now you guys will say, what we are doing? We are looking for single zero. If we'll find it, we are going to make an assignment and we will cross zeros corresponding to that assignment. Okay, let's start. So here in our first row, is there any single zero? No. First column, because there is no single zero, we will not make an assignment and we cannot, so we'll leave that row for the time being. First column, is there any single zero? No. After first row and first column, we are moving toward the second row. In second row, is there any single zero? Yes. So we are going to make an assignment and we are going to cross every single zero corresponding to it. So now the zero present is this one. We have crossed it. We have done second row. Now look at the second column. Is there any single zero? No. Look at the third row. Is there any single zero? Yes. So I'm going to make an assignment and I'll cross the zeros corresponding to it. Third row. Now let's look at the third column. Is there any single zero? No. Look at the fourth row. Is there any single zero? No. Look at the fourth column. Is there any single zero? Yes, it was, but now assignment has been done. Not a single zero, but zeros were present, and the both zeros has been whether assigned or whether crossed. Now again do the same process. Now again do the same process. Column, row, column, row, column. So there is any single zero in the first row? No. First column, no. Second row, no. Second column, no. Third row, no. Third column, no. Fourth row, no. Fourth column, no. Means that we cannot find a single zero now. So what we will do, we will start from first row and we will find two zeros, and we are going to make assignment. We can make an assignment on a random basis. We can assign any zero. We can make an assignment to any zero, but what usually we do, we are going to make an assignment from for the first zero. If we are making assignment row wise, then it is the from left, first one from the left. If we are making column wise, it will be the first one coming from top to bottom. Okay, so we are making assignment row wise, so it will be this one. So I have made an assignment and I am going to cross each and every zero corresponding to it. So here it is. I have crossed this one and I have crossed this one because it was corresponding to this one. So after crossing this zero, now again we will start in the same way. You can further find out that if there is a single zero, you can make an assignment. But what is the steps we have to follow is, again, first row, first column, second row, for looking for single zero. It is not about that once we have found the double zero, now we will look for double zeros. Once we had to make an assignment, whenever we are not able to find a single zero. If we have a 2 zeros, 3 zeros, we are going to once make an assignment, and thereafter again we'll try to find out single zero. But after making assignment to this, we can see that none we can find at single zero, just here. And you can see that it is possible to make an assignment because in this column and this row no assignment has been made. Or further, you can same procedure. You can take the first row, no single zero, first column, no single zero, second row, no single zero, second column, no single zero, because the zeros which are present in the column, those are assigned or crossed. Third row, no single zero, third column, no single zero. Yes, sorry, we have a single zero in the third column, so we are going to make an assignment to this. And third column has a single zero, so every zero corresponding to it will be crossed. So there is no single zero. We have made our assignment. We have made our assignment. So we are not in need of further improvement because number of assignments are equal to number of rows. 1, 2, 3, 4. Number of rows are equal to number of columns. So that is our actual solution we have arrived on. So how to write it? So solution, or we can say the assignment which chartered accountant should be assigned to which company, or which audit assignment should be given to which chartered accountant. Let's see. A, B, C, D. A will be assigned X audit assignment or X company. B will be assigned W. C will be assigned DU, that is dummy. D will be assigned Y. It means, and have a values. First of all, let's put a value, and we are going to put the values here from the original matrix. So A to X, that is 78. Thereafter B to W, that is 85. Thereafter C to dummy, that will be 0. Thereafter D to Y, 85. So our value will be 8, 8, 16, 16 and 7, 23, 24, 248. So that is our maximum surplus that can be generated through making assignment to different audit assignment of different chartered accountants. Okay. Okay, so here C has been assigned to DU means that C has no assignment. C has no assignment, and that is the, you can say, the effect of unbalanced matrix problem or unbalanced assignment problem. So C will remain vacant, or he will be free for the time. Okay, is it okay? Now that is the problem of unbalanced matrix, and you can say from the God grace we had to make an improvement here. We have got our matrix here, we have got our solution here. If by chance we were not having 4 assignments, we are falling short of 1 or 2 assignments, in that case we were going to do improvement as we have done in the balanced problem case. So I'll you can say I'll take one more problem on a balanced assignment matrix or balanced assignment problem. So wait for a minute. So students, this is our next question of unbalanced assignment problem. So you guys can see here that we have 5 operators and 4 machines. 5 operators and 4 machines, which means number of rows are not equal to number of columns. In that case, to make it balanced, or what will be our first step? To convert that unbalanced problem into balanced one. Okay, and how to convert unbalanced problem into balanced one? By introducing dummy row or column, whichever is required for a particular problem. So in this problem we are in need of a column. So dummy column, I am using DU word because we have already a D column. So values will be 0, 0, 0, 0, 0. Now next, whether this problem is of maximization or minimization. So if nothing has been given, you are going to take it as a problem of minimization. But if there is an information that it is something which should be maximized, then it is a problem of maximization. For the time being, we are considering these elements as a cost element, or you can say time element, production time or cost, which we want to minimize. So I am saying that is a cost matrix. That is a cost matrix. If it was a profit matrix, then what we have to do? We are going to find out largest element, and in that case largest element is 11. We were going to deduct every element, single element from this 11, and the resultant matrix was loss matrix, and the matrix which are going to came into existence will be the loss matrix, or will be the problem of minimization. So the steps we are going to start it from here. We were going to start that from here. After converting that problem of maximization into minimization, we were going to start that. Okay, so for the time being, that is a problem of minimization because it is a cost matrix. So that is a problem of minimization. So we are not in need to convert this into loss matrix. Okay, so we'll do row reduction and column reduction directly. So I think you guys have an idea that we have a 0 in every single row. And what is the purpose of row reduction and column reduction? The purpose of row reduction is to assurance of presence of single 0 in every row. And what is the purpose of column reduction? Is to making assure that there is a single 0, at least a single 0 present in each and every column. Okay, so from this you can see that we have a single 0 in each and every row. So we are not in need to do row reduction. we will directly move towards column reduction. Okay, as I'm writing here, as we have zeros in every row, thus we are not required to do row reduction. So we are directly moving towards column reduction. If you guys are going to do the row reduction, you can do, but the values will remain same because the minimum element is 0. So if you will reduce 0 from every element, the matrix is going to be almost same. So the same matrix will appear. So that will be a waste of time. That's why I am saying that you should directly move towards column reduction. So let's do the column reduction. So smallest element is 7. So 10, let's write it here, matrix A, B, C, D, thereafter D4, 1, 2, 3, 4, 5. You guys can write here E, it doesn't matter. I have written it as D4 for, you can say, recognizing it as a dummy column, nothing else. You can write here E as a dummy column. Okay, so 10 minus 7, 3, 11 minus 7, 4, 8 minus 7, 1, 7 minus 7, 0, 8 minus 7, 1. Thereafter smallest element is 4. 5 minus 4, 1, 4 minus 4, 0, 4 minus 4, 0, 5 minus 4, 1, 9 minus 4, 5. Smallest element is 6. 7 minus 6, 1, 9 minus 6, 3, 9 minus 6, 3, 6 minus 6, 0, 7 minus 6, 1. Next one is smallest element 4. 8 minus 4, 4, 10 minus 4, 6, 7 minus 4, 3, 4 minus 4, 0, 5 minus 4, 1. And the values will, for fifth column, that is D4, will remain same because 0 minus 0, 0, 0, 0. Here we have done column reduction. Now what is the next step? To make an assignment. So the way of assignment will be the same. First row, is there any single 0? Yes, we are going to make an assignment to this. We'll cross each and every single 0 present corresponding to this assignment. First row done. Is there a single 0 in first column? Yes. Make an assignment as the assignment was in the column, or corresponding zeros will be crossed. Done. Next, is there any assignment for single 0 in the second row? Yes. So we are going to make an assignment and we will cross the zeros corresponding to it in the column. Done. Done. Second row. Thereafter second column, no. Further we are not in need to look it further because each and every single 0 has been whether assigned, whether it has been crossed, whether assigned or whether it has been crossed. So let's move towards the next step, which is of the improvement. So let's find out the rows which have not any assignment. So let's have a look on this. Here it is 1, 2. So one by one we are going to look, is there any 0 which has been crossed in these rows? Yes. So firstly I am looking in this row. Is there any? Yes, here it is. So I'm going to mark it. After marking, I'll see, is there any assignment in this column? Yes, I'm going to mark it. Yes. Now let's check that in this row, is there any 0 crossed 0? No. So we cannot further mark it. Now let's check. We have seen 2 rows in which further marking cannot be done. Let's see this. Here is the single 0 which has been crossed 0. We are going to mark it. It is already marked. Next one is, here it is. So we are going to mark this column. Okay. and let's check it in this column. Is there any assignment? Yes, I'm going to mark it and check again in this row. Is there any crossed 0? Yes, it is already marked, so we cannot make further marking. Is it done? Now let's cover the elements. How to cover the zeros, or you can say cover the elements? Cover the rows which are unmarked. Here it is. Cover the column which are marked. Here, please remember 1. Done. Now we have 3 type of elements. First one is uncovered, second one is a covered but not at intersection, third one is a covered and at the point of intersection. Now what we do, we find the lowest element or the smallest element from the uncovered matrix, and the smallest element in this matrix is 1. So we'll reduce it from every uncovered element, add into every covered element with intersection point, and let the other elements as it is they are. So let's do it. Here it is. Our new matrix will be again A, B, C, D, E, 1, 2, 3, 4, 5. So 3 minus 1, 2, 4 minus 1, 3, 1 minus 1, 0, 0 will remain 0, 1 minus 1, 0, again 1 minus 1 will be remain same 1, 0, it will same 0. At this point 1 plus 1, 2, because it is the intersection point, 5 will remain same. Therefore 1 minus 1, 0, 3 minus 1, 2, 3 minus 1, 2, 0 will remain 0, 1 minus 1, 0. Therefore 4 minus 1, 3, 6 minus 1, 5, 3 minus 1, 2, 0 will remain 0, 1 minus 1, 0. Again 0, 0, 0, and at this point there will be an addition, 0 plus 1, 1 and 0. Again we will start making assignment. So is there any single 0 in the first row? No. Is there any single 0 in the first column? No. Is there any single 0 in second row? No. Is there any single 0 in second column? Is there any single 0 in third row? Is there any single 0 in third column? No. Is there any single 0 in fourth row? No. Is there any single 0 in fourth column? No. Is there any single 0 in fifth row? No. Is there any single 0 in fifth column? No. So next what we can do, we haven't find any single 0. Next what we will do, we will find any row or column with a double 0. So let's start. Is there any single double 0? So we are going to make an assignment to this as per our preference in this video, as I have told you earlier. So we are going to cross every single zeros present corresponding to it. Done. This way. Next, again we are going to look at, is there any single 0? Now first row, first column, second row, second column, third row, third column, fourth row, fourth column, fifth row, fifth column. No. Again we have to make a random assignment. First row, first column, no. Second row, is there any single 0? No, but double 0, yes. So we are going to make an assignment to this, and we will cross every single 0 corresponding to them. Done. Now again look for single 0. No. No. Okay. So now what will be the next? Third row. In a third row we are finding 2 zeros. So we are going to make an assignment to the first one. Done. And we'll cross this, this, this. And now again, is there any single 0? In this way, yes, here it is. So we are going to make an assignment to this, and we will cross it, because first row, first column, second row, second column, third row, third column, fourth row we are finding a single 0. So that's why we had made an assignment and we have crossed the 0 corresponding to it in the column. Crossed. Now the last assignment will be to this. Is it done? Now check that whether we have reached our solution or not. Let's see. 1, 2, 3, 4, 5. Yes. So number of assignments are equal to number of rows or column. As I have assigned, as per my assumption that every first zero, if we are making row wise, if making column wise, then every first zero from the top. In that way I had made an assignment. Okay, otherwise it was your choice that you were in the first instance you were going to make an assignment to this. If you are going to make an assignment to this, you are going to cross every single zero here and also this. It may lead to, but the solution will be the same almost. The assignments can be differ, but solution will remain the same. Okay, so let's see what's our solution. So 1 to C, 2 to B, 3 to A, 4 to D, and 5 to E, that is dummy. DU or E, I have used word E here. The values are 1 to C 7, 2 to B 4, 3 to A 8, 4 to D 4, and that will be 0. 7 4 8 4 7 4 11 8 19 23. That will be the minimum. So we may have a different assignment, but our answer will not vary. It will be 23. It cannot be minimized. Okay, is it done? So that is our solution. Okay, have a good